Hello, Professor. This is the weekly review number 8, and I'm using my notes to answer the questions. And the first question was about a schematic, talking about how the SREP is activated, and I'm gonna be drawing that. So first, for the schematic, the SRBP is activated because of the low cholesterol. So first, the SREBP is activated because of low cholesterol. I'm just gonna put col there because it doesn't fit. Then the activated SREBP, it's already active. It's gonna, since the SREBP is activated, it's gonna get out of the nucleus and bind, it's gonna get to the nucleus, So the SREBP activated is gonna get to the nucleus and it's gonna bind to the SRE on the LDLR gene. Activated will go to the nucleus and bind to SRE on the LDR gene. So we can draw the gene, the LDR gene, with the promoter region, with the total box, and then the SREBP will bind to the SRE and the LDR gene. And after it binds, the SREBP is gonna enhance the transcription of this gene. So this will go for transcription. And this is because since the SREBP is active and binding to the LDLR gene, then transcription can occur because the SREBP enhances the transcription. Now the LDLR for the next step, the LDLR mRNA is then translated into a protein. Into the LDLR protein. So I can just write that LDLR mRNA goes through here, translated into LDLR protein, goes through the ribosome. This is the ribosome. For the next step, after the LDLR mRNA is translated into LDLR protein, the LDLR is going to bind to the the LDLR protein will bind into the circulating LDL over the cell, the surface of the cell. And after the LDLR protein is binding into the LDL is degraded. So the LDL is degraded, and as the LDL is degraded, it's gonna release the cholesterol. And after the cholesterol is released, then the LDL is degraded, so the cholesterol is released, and that would inhibit the SREBP activation and transcription of mRNA. So if the cholesterol is increased, it will inhibit the LDLR activation and will also inhibit the transcription for mRNA. So it would inhibit the transcription if the cholesterol increases. So that's the scheme I feel like I could have done it way better for like a drawing, but it's kind of hard to do like a drawing. Anyways, I'm gonna go to the questions. So what would happen in a cell once LDLR mRNA levels increase? So the cell, what would happen so for the cell, what would happen is that the cell would produce more LDLR so we'll produce more LDL protein, and since the cell is producing more protein, then the protein is going to go to the surface of the cell and will bind to LDL. So when we go to the surface to bind with circulating LDL, and then the LDL uptake in the cell is going to increase. And this is gonna increase the LDL uptake in the cell. So if the cell LDLR, so if the LDLR mRNA levels increase, then the cell will produce more LDLR protein, and this will cause further increase of LDL uptake in the cell, so that cell will need more LDL to produce more proteins and more cholesterol. And what happens? Okay, let's go to the other question. What experiment can I perform to determine if LDL protein is active? So to determine if LDL protein is active, we're gonna do the luciferase assay. And we're gonna do this because in the luciferase assays, the LDLR is active. That's the second time. The LDLR is active, and it should activate the expression of the luciferase. So, yeah. And what experiment can I perform to measure the amount of LDLR in mRNA? So I would do the quantitative reverse transcriptase PCR, and I would do this because the RNA is extracted from the RNA is extracted from cells, and it is reverse transcribed. So RNA is extracted and reverse transcribed into complementary DNA. And the complementary DNA is then gonna be amplified, or it could be amplified in normal PCR. And some predictions that I could say in cells with low cholesterol, if I have like a plate treated with MK2206 and an untreated plate, I would say that the untreated plate the level of the LDLR in the untreated plate could be expected to be low, depending on the low cholesterol conditions. And in the treated plate with MK2206, I would expect for the LDLR to increase, or would it decrease? I would say it would depend. It could increase or remain unchanged, because if it decreases in the untreated, then on the treated it would increase, but it could also stay the same. It depends on the cholesterol conditions. Thank you.